Alright, so the first question is, why is the flow near the pipe wall in turbulent flow more laminar than the flow in the center? And this is essentially because turbulent flow is caused by the momentum losses where the water flows in the radial direction or between the layers that would be in laminar flow. And because the layers are moving at different speeds, the water moving back and forth between causes momentum changes and energy loss. Now, the reason near the wall it is more laminar is because there's a lot less radial movement in the water or movement between the layers, and this causes there to be less turbulence and therefore causes the flow to be much more laminar. Now, for the second question, you have a 20-meter hose and you need water. They're 22 meters away since it's 35 degrees outside. You need to find the diameter and the inlet pressure to achieve the flow. And the hose has a diameter of 3 centimeters, a height of 1 meter, and an inlet velocity of 1 meters per second. And the thumb on the end of the hose can be treated as a sudden contraction. So we know D1, the length of the hose, the temperature outside, the velocity in, and the height. We are told to find D2 and P1. We can assume the kinetic correction factor is 1 and the pressure 2 is equal to PATM, which is 101 kilopascals. And then because we're at 35 degrees, we can go to the water property tables and get density of water and viscosity of water, and G is 9.81. We start out by finding the necessary velocity out of the hose by essentially finding the time it takes for the water to fall 1 meter, and then multiplying that, or dividing that, and then taking the distance it needs to travel divided by that time to find the outlet velocity necessary, which is 4.43 meters per second. Then we can use that to find the diameter that is needed to achieve that velocity, because we have the diameter in and we have the velocity out and the velocity in, where the velocity out is 4.43, velocity in is 1, and diameter in is the 0.03. And so there's the first part of our question. Then the second part, we find Reynolds number, which tells us that the flow is laminar, the friction factor, and the KL, which can be defined for the sudden contraction, as said in the problem. We can then find the head loss, and then plug that into the Bernoulli equation to get an inlet pressure of 161.74 kilopascals.